Aha! Yes. Yes. Oogabooga. Oogabooga. Hello and welcome to the first ever coding session with Leibniz. Now, in this session, you will now see my dwindling sanity when it comes to programming itself. Let's first keep our papers. This is a problem if you're a streamer and you have only a single monitor. But yeah, first I need to create stuff. So, anyways, before I start, it's time to create the ultimate code here. The ultimate code, the creme de la creme, the moment that you've been waiting for, is the ultimate Oogabooga counter. So yeah, it would be every time I speak a word, this phrase Oogabooga, on my stream overlay here, it would create a counter. So first I said Oogabooga, then I've said it 1, and then another 1 plus 1, and then plus 1 and plus 1. Now, of course, you might be asking, how do we do it? What kind of coconut sorcery, coconut magic do we need? Well, first you need some good codes, okay? And a good programming language. So I chose a programming language called Python. It's a very good programming language to use and learn and do stuff. But yeah. So for those who haven't a slight idea on how coding works, essentially just send instructions to a computer. That's simply it. You need to speak their language, the Oogabooga language, just so you can relay some instructions to them and give it back to you. So for example, I want to print some Oogabooga right here. Oogabooga. Yeah. Oogabooga right here. So if I run this, Oogabooga gave me some stuff here. Well, anyways, enough dilly-dallying. It's time for our good old code. So first, we need to set our game plan first. So how does voice recognition work? Of course, you need to get some inputs. So you need a voice. Then this voice would be served as our input. Then as I speak the phrase Oogabooga, the transcriber should recognize the word Oogabooga. And then it would do some back-end codes and stuff, and then output it on the stream, which is our Oogabooga counter. Now, after this code, I'll try to share it on GitHub so that our fellow programmers can see what I'm doing, what kind of hellhole I've done to them. Yeah, that's pretty much it. Anyways, so first we need to focus on what type of transcriber to use. As you can know, Google has its way, right? So every time you speak some "Okay Google," and then it would speak back right at you because it understands the keyword "Okay Google." They have this sort of a analyzer that crunches your voice. Yeah. So in any case, I have chosen a good model here. So there are different types of models that you could use when it comes to Python, and one that you could easily search is that you could download the speech recognizer or the speech recognition module from Python. But for today, I'm going to use something that's new, Okay, let me hold on. I'm going to use a deep speech, created by the Mozilla Firefox. So hopefully this is good, and hopefully my dependencies are right, because I'm just basing this from here. So before we get started, let's first install our deep speech. So first, we need to have our Python. This is our main goal here, our main programming language. Then let's install our deep speech. So it's kind of quite simple. Just type install deep speech. So we are getting some data from the GitHub server. Since I don't want to make it from scratch because people did that. I don't want to reinvent the wheel. Oh no. Bathwater program. No, please. Stop. Anyways. Yeah, I don't want to reinvent the wheel and create my entire new transcriber. It takes a lot of work. So I did not know that this would take long. So yeah. So first we need to install our stuff here so I can use people that. So our version that we're going to use, it's deep speech at 0.8. So this should be one of the latest here. I haven't read the proper documentations yet. Yeah, we're going to use the models here. Yemen. And the scorer. Oh my. I did not expect this. Oh wow, this is Yo, this is yo. Wait. What? In any case, let's first check our dependencies first. Import wave. Yeah, we have this thing. NumPy. Stuff. Yeah, I also need to install the port audio. Why didn't I install it? How was it? I did not expect this to be big. Okay. We're off to a great start here. But anyways, as this goes on, I'll ask you viewers if you have any prior knowledge to programming. Have you tried programming? I don't know. I mean, it is a course, I don't know, a study that isn't well known unless you have delved into the internet so much. Since we're waiting for our downloads to finish, yeah, it takes so long to download. Yeah, hopefully my internet won't die. I'll try to teach you the basics of how to code. So in Python, it's one of the high-level languages, and there are simple logics in programming. First, you need something that contain a thing, something that can contain something. That's one. And then we need to check our conditions. Then the keyword would be if and else ifs. That. So first are variables. So what are variables? So these are the type of things that you could put in. For example, I want dog, or for example, a name of a VTuber that shall not be very careful with Pengu, and then tuber. Yeah. So this thing here is the name of our container, dog, and this is what it contains, which is bruh. And you could store some numbers and stuff. 1, 2, 3, 4. So we could do some operations here, like if I do that, you got yourself a 14. 12 plus 2 is 14, so that's big brain math. Let's see. 6 minutes. And hiccup there, so 3 hours. We install this again. Pip install deep speech. 0. Deep speech 0.8. Numpy, okay. So you're wondering why is this very large? It is because we're downloading basically an artificial intelligence. It's kind of like that, but not in the way you think, because this is the type of thing that has been trained by stuff here, that has been trained to recognize speech. So you're basically downloading a brain from this, and it is for free, so anyone can use it. Yep. Old. Every time you install, I'll check that it's running. So, you could import deep speech and with it. See, as you can see, there's no errors here. Okay then. Voice, here we go. Deep speech. Let's copy this real quick. Oh yeah, I need to install port audio. Deep install. Oh wait, I need to download this one. Probably want this. Yeah, sure. Audio. What? Audio. Oh my god. This is this third. Oh no. Oh no, what's happening? What's happening? My audio. I must win 60. You should be specific then. Search by 64-bit. Is it AMD? It's 64-bit AMD. Okay. Folder. From the CD. install by audio. Ew. Oh, yeah. Ah, I see. I understand. So it should be Python 3.8. This should be it. 38. And hopefully this should work. Hopefully? Question mark? Okay. Yep. We have my audio now. Port. Okay. Did I download? Okay, well, I'm using PyCharm, so don't need that. Anyways, let's try importing my audio and see if it works. Okay, so everything works so far. Now we're going to make our first step, is building our transcriber. Okay, this should be done any moment now. Come on, don't be shy. Yeah, I need to create a new folder here. Forgot about it. A voice record. Put it here on voice factor, and then see. Oh. I think this should be done. Put it in here, so we have ourselves the DS. Let's say DS underscore DS underscore models, and there. Now let us build our deep speech. Now first, let's import speech. Okay, this should be good. And then let's first specify our container here, our variable named model. Let's go with model path. Model path. I think we could go with the DS score here. This should be good. This score. No, no, no. DS mod. Deep speech model would be fast. Then, after initializing our model here, for better accuracy, hopefully this works, because it's either I'm going to use this or not. I don't know if Oogabooga is an English language, so. Yes, score dot score and then you know what? Let's rename this Oogabooga model. Oogabooga model. Oogabooga model dot so based on this, we could safely assume that this should accept the score. Oh. This should be the initialization of initialization. The right spelling. Initialization. Set scorer. Yes, set scorer alpha. Yeah, this thing is kind of the range on how accurate would be. Like there should be a range of values that gets closer. How do I explain this? You know, in an exam, there are test scores and stuff. It kind of compares them if the one that you've analyzed is close or very near to a certain group. And yeah, I hope I haven't butchered that explanation. Oh my god. Spelling here. Yeah, we should normalize our stuff here. Data, because I'm going to tweak this for thread with yeah, or streaming stack. Open session, feed data. Data 6. Audio open. Let's look at the code here. I think he used a while loop here, if I am right. Oh, the stream that starts stream. This came from the audio of Pi Audio. Okay. Model that. Oh. Please start speaking and done controls. Okay, so it doesn't detect. Okay. Yeah, well. I see. So it's kind of like of a recorder, but it doesn't constantly getting the data that we want. Don't worry, I could find a solution here. So, as good coders as we are, we're going to get the code from other people. So, just copy paste everything. Easy. This is how programmers work. We just copy code from people. We're going to import our Ultimate Pi audio. Hopefully this works. And that's deep. Okay. NP. Yes, and okay, we're going to use our Oogabooga model, creating session here. Ooga model. Wait a minute. Yes, stream. What's this? I created a stream. Specifically here, context. Context here. Need audio content. So this should work. Feed. We go with context here. model that creates string, and then we have contacts. Based on this context, we have ourselves buffer. I think he uses 0.61. I see. So they made it easier now. Audio buffer, not by the in array. Intermediate decode. Stream dot create stream. So we got yourself a streamer, then streamer. Intermediate decode. What does this return? The STT, speech to text intermediate result type string. Feed audio content. It should feed. Oh, hello Tiaro. As you can see, you can now feel my pain because I'm dying. Anyways, back to our code. Okay. So we have our data to feed, which is my voice, my wonderful voice, converted into a NumPy array. Then here's the streamer, the audio content. It's okay, it doesn't learn something good. Main info. Info. If our info, okay. Return in data. I don't even know if this will work. Oh, yes. Yeah, okay. Intermediate code. Process all. Okay, from which start stream? Would start streaming. Then after that, if the after close recording text but how does it audio? Oh, stream callback process all. Yes. A name tag is not defined. How about test? Oh my god, my brain is hurt. My brain is hurt. My brain is hurt. Hello? This text is not defined. Hello? Oh, it should be info and then text. Oh wait, info. Oh, my bad. My bad. And then this should be the text and then text. Oh my god. My brain died for a moment. 1, 2, 3. Whoa! Whoa! Testing? Testing? Hello? Hello world. Hello world. Hello. 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 Yes. No. Maybe. Yeah. Nice. Yes. Yeah. Oh. This actually worked. It's actually working. It's actually working, but what? How? How? Okay. But what if I what well, I know it's it's actually working. Oh my god. My god. God. Okay, let's see. The internet text, this is how the info on the spot. So let's on the second. Hey to you all. How are you doing? How are you doing? Yes. Okay, it's not. Oh, it's not working. How about this instead? Okay, I'm going to run the voice recognition here. By voice recognition. Hello? What are you doing? Yes? Oogabooga? Oh no, he doesn't recognize the Oogabooga. Ooga? Ooga. Ooga. Oogabooga. Oogabooga. Oh no, this is... Okay, this is... Okay, so here comes the problem. Recognize my voice, as you can see here. It doesn't, well, recognize it well. But it gets the job done. This is actually interesting. But how do I... I say Oogabooga. Oogabooga. Ooga? 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 Oogabooga? Oogabooga. Bulgaria. Bulgaria. Yappe. Okay, so what would happen if I remove the... If I remove this scorer instead? Something happened? So I'm going to comment. And let's see if this works now. Testing. 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 What? What? Bruh. Oogabooga. Oogabooga. Who got testing? Bruh. Hello. Hello world. Help me. Help me. Ah! Getting there. Okay. That don't work. Let's read the documentation. This is hell. Okay, good. So at least we got it working. Now we need to understand how it works. Okay. LM Libris 0.93. Documentation, please. I need documentation, please. Wait, I could train my own model? I could legit train my own model? Wait, I could train my own model? Oh, this makes my life easier because I could just input, let's say, record myself saying Oogabooga 500 times. Oogabooga, 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 Ooga. Yeah, well, this is actually good. Not gonna lie, this is actually good. Now, if our previous problem, no solution rather, not work, then I could use this instead. Create my own model that recognizes only the word Oogabooga. Nothing more, nothing less. Okay, let's try this again. Beam with. Beam. Set beam width. Okay. A larger beam width value generates better result at the cost of decoding time. Oh. Well, okay, let's try this. 0.93, right? Go for 0.90. 1.18. Let's go for 1.25. 0.93, let's go 0.85. Now the margin of error would be smaller here. Testing. Dusting. Hello. Hello world. Hello world. This is a test. This is a test. Testing. 1, 2, 3. Oogabooga. 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 Booga. 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 Oh. Oogabooga. Yes. Yes. No. Yes. No. Again, open speech to text engine versioning. Resource constraint. Okay. Oh, the acoustic models were trained on American English. I see, I see. So in the end, we're going to. Oh my God, this will be long. Training a model would take time and energy. These speech oh dependency. 3. If you have a capable NVIDIA, at least 8 gigabytes of VRAM, it is highly recommended to install TensorFlow with GPU support. Oh my God. Oh my God. Okay. Import cv2.py filter. And this is sampled by their absolute class. Ooh. Thank you, Chris, for the follow on my Facebook. Now, first example. Repeated on the GPU in a few minutes. Here you can alter anything. Oh my God, what's happening? What's happening? What? What? There's a lot of people following. So back to our stuff. So I need a good GPU to train my model. To those who are wondering what is training a model, basically I have a brain here, okay, and this brain needs to learn stuff. So we gonna train that brain using my good old PC. But my PC as of yet isn't that strong, so it's either I'm going to use a cloud stuff or get another computer. No, PC rather. No, wait, computer. Yeah, that's the better term. I could get faster stuff. Ah! Oh, wow. Oh, there are two guys. So I could fine tune. Specify the path where you download the checkpoint. Release my train. I see. Oh well. Oh my god. That's a lot of text. That's a lot of text. Oogabooga. Oh, that's broke again. Oogabooga. Keyboard interrupt, please. Well, okay. So, as of now, the Oogabooga has progress. We have a transcriber here, but it doesn't recognize the word Oogabooga. So, we're going to fine-tune that, put my voices there, and it should be good as new. It should be good as new. I don't need to create it from scratch. You just very interesting. Well, we know it works because it is constantly streaming. Of course, for every print of interim text, we're going to info. That's format info. Intermediate decode. Are there other stuff in it? Intermediate decode, finish stream with E. Well, anyways, I'll cut this stream short. As we have reaching our 1 hour limit here. So yeah, hopefully you have learned something. Well, to those with coding background, just to recap. So we have made a transcriber that could convert my speech into text on real time. There's no delay, as you can see if I going to run this code again. Pi. As you can see, it. Wow. As you can see, it gets my speech, my voice, converts it into text. So it's not very accurate because my accent isn't American English. Okay. But does get the job done. Now, Oogabooga is a foreign language. So that's our problem here because there's no such thing as Oogabooga in the dictionary as I make it. So anyway, first we've used deep speech instead of speech recognizer because Google likes to limit their users and I don't want limiting stuff. As you can see, oh wow, it keeps going. Anyways, I used Pi Audio just so it could process the audio from my mic. You see audio that it opens the mic and processes it real time, converting it into a NumPy array in 16-bit, and then we have ourselves a model, which is our brain here, interprets the words that I'm saying based on this model. See, there's the Oogabooga model here. So what I'm planning in the future is that I could record myself saying Oogabooga probably 500 times, 1,000 times. The worst thing I could happen will be 5,000 times of Oogabooga, just so I could fine-tune it in a way. And another problem that I may encounter is that training is hard and it would take probably a lot of time. So I do need your new ideas, special new ideas, as I end this stream, because I don't want to stream a training part of the program because you're just sitting there staring at the screen waiting for it to finish. It's going to train by itself. But if you do have brilliant ideas or some weird and outlandish ideas, I could convert it into code, like for example like Michael Reeves did. Whenever someone on Twitch subscribed or donated, Michael Reeves I think drill would turn on. So I think it's just a simple use of webhooks and stuff, but it's quite interesting to see again. Or I also made a Hololive rock paper scissors game, but that wasn't finished yet because I got lazy as usual. Well, anyways, so thank you all for joining my channel, and it's quite a good thing I never went to Stack Overflow yet. It's good. Oh, and please stay tuned if you want more coding tutorials like this, because in the future I'm planning to give the very basics of programming using the Python language. I'm going to teach you guys how to code, and then we could hack through time. Yeah, don't do that or you're gonna send to the Oogabooga realm. Okay? So as I end this note, thank you all for watching. Hopefully you had a nice day. Well then, thank you and goodbye.